Alright, in this session we're going to show how to run the code generators for the whole project. Basically what I did here is I went in and added some new things. Look under program. I added this here, use advanced reports. Also added a couple other things, imagine card ID, so there's a reference from this object all the way to the card object, this one here, their imagine card, and then a couple other changes. So if I go in and run this to get the SQL script change, I'll go ahead and add it into under the project. I go to the doc for documents, go to Derby. There's a bunch of them in here, and I'll go ahead and add it in here. Change that, and that generates this file here. So now if we go into the project under doc, under Derby, here's the file. Here it is pulled up here. If I look at it here, it's got all the SQL statements that I need to run on the database. So I'm going to show how to do that next. Before I do that, also in this doc Derby directory, there's a database.txt, which has just got some notes in here, kind of a cheat sheet. But at the top of it, it has some notes on how to update the database. So that's what we're going to do now. We're going to take these changes and apply them to my database. Open up a DOS window. And then my database on this system is in runtime server. And one of the things to keep in mind is you have to stop the program for this, because we're using an embedded database and only one process can have it open at a time. So IJ is the command. Type that in, and that basically is going to run the Derby command prompt. And then from here I can connect to the database. I'm going to show that next. So if we go here, here's runtime, here's a server. Under the server is database, and then under here is all the files and stuff needed for the database. So the whole database is stored in this directory, not one file or anything like that. So in here there's the log, and then there's a segment that shows all of the DAT files that store everything. And this database is now called JavaDB. The open source version of it's called Derby. The original version was called Cloudbase, and that was like 2000 is when that was popular. So I connect to the database here, not connected anyplace else, and then I do a auto commit off, and that will allow transactions so I can roll back or commit them just in case there's a problem. Just while we're here, every command has to end with a semicolon. If you don't type one, it waits until you do put one. Help brings you up a list of commands. You can do all your SQL stuff, and then there's some other stuff. The show commands is good. Show tables, show you a list of your tables. Describe the name of a table, will show you all the columns and stuff. But usually I'm just going off the model. If I need to see something, I can see it in the model, and it has all the information there. But sometimes if I have to do some SQL and stuff like that, I can go down here and into the prompt and see what's going on. If I need to move some data around, clear stuff out, I do it all here. And the other thing, of course, is I'll go in and update the database. So if I have a script, which I have here, one thing I can do is I can take this script, I'm going to make a copy of it here, copy, paste, just paste it here just to make it easier, because from the IJ prompt I can type in run and then the name of the script. then I run it. I'm going to roll that back just to show how that works. And then a lot of times what I'll do is I'll just cut and paste these commands in here, because I want to just make sure they're all going to work first. So I'll take them in bunches. By the time I send them out for everybody's update, I made sure they all work, so they can go ahead and do what I did last by just running that. But whenever I'm working on the changes, I'll usually put them, I'll look at them, make sure that what was generated is correct, because every once in a while there's some stuff that's not correct that needs to be tweaked a little bit, and then I'll just paste them in here. So I just do a copy here and right click here to paste it, and alter table, yeah. So I'm going to roll this back. It's not really a problem, but it's a warning. We created a foreign key, and for Derby it will automatically create us an index to go with that. So I'll comment out that index code, run that again, and that's set up there. And then all these other ones are just adding new columns, so I'm going to copy that, paste it. All that looks good. Go ahead and commit it. Quit. Okay, if I don't quit, then when I try to start the High5 server, it will not start because it won't be able to open the database because another process has it open. So just keep that in mind. So the model's been changed, the database has been changed to match it. Now what we have is we have all of our code, our application needs to be updated. And what we're going to talk about in this session is exactly the code that does get changed, so we kind of know the boundaries of what the code generator is going to generate. And then we're going to then from there look at other areas in the code that also work with that, but it's not generated code. So for code generators, I'm going to generate the OA object classes. This is going to create a class for each one of these. It also creates a class for each one of these with the name search appended on it. So there'll be a program search, employee search, and that will have properties in it for the searchable properties, inputs, parameters or whatever. It will also create filters. So whatever the name of these are, with the word filter appended to the end of the name. So we'll look at those. So we just generated those. If I go back to Eclipse, I'm going to need to refresh my project. Now if we look at the files, they are all under model, and then under OA. Okay, all these were just generated along with, there's the filters and there's the searches. So again, the name of it has the word search on the end of all of them. Let's look at program here first just to see an example for the layout. We won't go through the whole thing, but every one of them is laid out the same way. There's some annotations that's consistent with all of them that describes it with the information that's in the model. So it's available in the program and how it does all the stuff that it does. And then all the properties are here, and a string value for the name of all these, because we're able to use in our binding and stuff the actual name of the property. So instead of typing in the string, we can use this value. It's quicker to type in because of the IDE's autocomplete, and it's safer because we don't have to worry about typos. But here's all the properties. Here's all the references. And then within the code, it has all the getter setters. Okay. Along with this code, the kind of cookie cutter part, the properties and references and stuff, is there's also we talked about before, calculated properties. It's also generated in there. Calculate property has a formula, which means it has some kind of code. So that code's in here. As we loop through here, we'll notice that the code's pretty small. And the code's really calling out someplace else to actually run it. And we'll look at that here next. So this code that goes in here is actually what was that? is that employee? Wrong one. So if we look at employee, look at is manager, we'll see that that code from here is just entered here along with information about this calculated property. So the information again is coming from the model that's needed within the application, so it can know how to manage and set up that calculated property. So whatever we code in here is going to show up in there. If we have methods that we want added there, this is the code that has all those methods, so you can see all that. There's also any imports. So within the object, extra code that we put in these different areas, and I'll review that here in a second, is added into this file so that ideally we never have to touch it. What I'll do when I create something new, I'll put it in here first, and then I'll cut paste the code into its correct order here, and then whenever I regenerate it, I know it's already there. So for the OA objects, for each object, there's the import code at the top. So if there's any extra we need to add in there, we'd put it here. Most of the time we don't. Employee objects a pretty busy object, so it's got a lot of extra custom code and stuff. If there's any filters, there's code for that. And again, it's kind of like a formula, but in this case it wants to know if, given the object, does it belong in a filtered list, you know, for whatever purpose we have it here. In this case, anniversaries or birthdays. I'll show you, we'll look at this code here also next. And then under the properties, most of the time it's just a get set with cookie cutter type code that gets generated. Every once in a while we also want to add something else there. I don't know if we have anything necessarily in with any of these that we can find, but if we want it to, we can just say generate the code, and it would basically, here's what it would generate it otherwise by default. So basically it's got this, the getter, the setter, and then it fires a property change just because the we talked about before, the fact that they're observable and stuff. So that's all built in. I think that's it. User interface, we can generate the code that would, and we can customize this for the rendering of how it shows up in the tables and stuff like that. Other than that, everything's pretty much handled for us. Calculated properties, we talked about that, how that code goes in here, and that's going to be generated with it. Any references, so if we click on one of the references and it has custom code, we would see that with it. This is a calculated one, so we have to have custom code for it to figure out what that is. Another one would not have, like this here. I guess this one does too. This one doesn't. In most cases it doesn't, it just says get to reference and stuff, but every once in a while, again, especially since employee, there's some busy stuff going on. But what's nice is it's kind of hooks. So here, whenever we set the employee, we have it doing something, something a little bit different. And again, when this gets generated here, this will all be included in that file. So this allows us to kind of have the central place where it all gets generated from. Okay, one of the things we saw when we looked at the calculated property is manager. We saw that it was calling out to this employee delegate. Okay, employee delegate's not generated. We have a package called Delegates, and delegates are basically, it's a good place to centralize your code, and it's a delegate basically means it's code that works on something. So in other words, in this case I have an employee delegate. That means it works on employees. It does stuff for a reference to an employee. So what I can do with that is that keeps kind of all that custom code organized. Doesn't have to be that way. I could have put it in the object. It's nice to look at the object and have it mostly just get set all the way through it, and maybe some custom code for firing events and stuff like that. But any big calculations or anything like that, it's nice to kind of push off in some other code. So until it gets too big, I always just put it in a delegate. If it gets more involved than that, I'll put it in maybe, you know, another class or something like that. But for the most part, this seems to work out pretty well. under the delegates, just like under the model, is the OA. OA being OA object. So under here is the delegates I have set up. So here's my employee delegate. If I go back to that class, employee delegate is manager, I can see the code. Since it's a delegate and it works on objects, in this case employee objects, everything's static. All these methods, I call it, I give it the employee I want to work on or I need a value from, and then it will return that. So putting this code back into the object, all this would still work the same. I really don't call this from outside of it or anything. There's nothing special about it. Again, it's just kind of moving some of the bulk of the code out so the code's a little bit more readable and a little bit more organized. Then when I look through my code, I can kind of know that my employee object has some extra code going on with it. Just by looking in here, I see that I only have 5 delegates, so I pretty much know that all my other objects in here are pretty much getter, setter, normal, cookie cutter type stuff. And then all the custom, I can know from this that there's custom methods and stuff like that. The other thing as far as the objects themselves that get generated, we talked about the objects in the model under OA. All of them are there. We mentioned a little bit about the search objects get also generated. Okay, our employee object has all of its property information. The employee search object has properties for all the things that I pulled up the wrong one, that we want to search off of employee, and it can be as many things as we want. And it's different than just an employee object because employee object just has information about the employee. We might want to search off of something far-reaching from employee, like maybe the program they're in or an order that was made, and then tie that back to using that for a query to select all the employees who have an order with certain conditions or something like that. So this object isn't just information about an employee, it's information about searching for employee. So it's another OA object. Everything's laid out the same except for a few things. It's not a persistent object. It could be, I guess, if we wanted it to be, but it's set up so it's got some annotations just like the other OA objects, except it's got some information that says it's not persistent, it's not you're going to use a database, it's not cached, it's local only, it's just some stuff like that. And again, this is pretty much cookie cutter code. This is all generated. Never touch this. The other thing that this does have in it is it will take all of this information in here, all these query parameters, and it adds a couple extra methods, helper methods and stuff like that. One of them is to reset, so we can set them all back to empty. Another one is to, has any data been entered, because there might be a pop-up search screen that shows all of these inputs that you could enter in to build out your query, and when you hit search, if you didn't enter anything, we want to know that. So this is just a helper method, just checks every one of them to see if anything's been entered for search criteria. And then the most helpful one is a method to actually build out the query and return a select. And this OA select is a database independent way of querying databases, and this select object is basically an iterator. So I can build out a query, then use this select object. It will then, its job is to find the data source object that has the JDBC connection and all that stuff for us, and it will send the query, and then it will get back objects from that. The JDBC connection and all that stuff, the JDBC data source, is it will use a result set. It knows, because there's a, and we'll talk about this in a minute, there's an ORM, there's a mapping that will, instead of returning the result sets from JDBC, it will manage the result set and actually populate objects for us. So this OA select will give us an iterator so that we can get the next and iterate through all of the results as objects instead of result sets. So what this will do is build out the query. It takes all of the query parameters, properties that you can use for querying, and strings them all together to build out a query. And if you kind of go through this, it looks like it's building a SQL statement, which is pretty much what it's doing. It's based on the object structure. Then what it will do is build out a select with that SQL statement. If there's a sort order, go ahead and put that in there, and it knows the SQL along with all the arguments. And again, it goes through the whole process. In our case, in most cases, it's going to go to a relational database using JDBC, have the results set, and again go through the process of having them returned as objects. And while we're on that subject, part of that process and part of what's generated into the objects themselves, in this case back to the employee Java, is a method that will actually load this object up, this class. So if a new employee object's created, is it can be given the result set, and it will automatically populate itself, populate everything in here. So this is set up just through the mapping layer and everything else. This will go ahead and get done. This doesn't have to be here, but performance-wise and some other things, it makes a difference. So that's why that's generated. But if this wasn't generated, by default, is it would use reflection to go ahead and populate this whole object once it's created. So that's the delegate, the database, the search object. The other one is filter object. Okay, filter, again, just like, all of our objects don't have filters, but on any of our objects we could build something that says, we can build filters on it to say that we want to be able to take a list of these objects and then filter those into another list to be a subset. And here's all the ones, and again, in OABuilder we can go in there and actually model those out. So if I'm on employee, we look at the filters. Here's one to find everybody who has a next anniversary. And there's parameters that go into that based on hire date, based on how many display days we want to show it. So those are the input parameters. And if we look at the employee filter, this is all generated, and it will basically create a filter for us for each one of the for the object for each one of the filters that we have defined in there. And then we'll see in the code how you actually could actually have a hub of employees in this case, and then have another hub that's empty that will automatically be populated to always show all the ones that meet the filtering criteria. Another example would be we might want to at startup find everybody who has a birthday this week, and that's one of our filters. So in our code at startup we would have a SQL statement that would select everybody with a birth date within whatever this week's range, and it would then run them through the filter just to make sure, because sometimes our filters is more precise than what we can query the database from. So it gives us that extra benefit of having our query to the database just get it close enough, and then the filter will fine-tune the rest of it out. But the other thing it will do is it will keep the filter, or the filter will keep that list up to date at all times. So if somebody gets added to the system with a birth date in the next week, is it will automatically add them to the list. If somebody's birth date's changed that shouldn't be in the list anymore, it's automatically updated. Again, that doesn't have to work that way, but if you want it to, it's all that's built in there, and it's kind of how these are set up to work. And part of the model is you can tell it at startup, you know, part of your UI, you're going to have a active list that shows that, and that's what we would have here. Under next anniversaries and next birth date, down here we can say we want this to be part of the server root. Server root object is the top level object that up front will go ahead and select some stuff, and then the UI, the client UI, would automatically have that as one of its listings and stuff that we could navigate to. Alright, so we did the objects, the search, the filters. We talked about the data source some. The other thing I want to talk about, we talked about the controllers. No, that's the next part, controllers. We talked about the delegates. The OA delegates are here. And then controllers. So what we have is we have the object code itself with the information about it that comes from the database and populates and everything. We talked about how we can filter those, how we can have a search object for those. We also talked about the delegate, so we can kind of move some of our code over into the delegate object just to organize it. And then another thing that we have to do with our data is to be able to have things processed, or a controller component. So when certain conditions happen, then something needs to kick in and do something else. Maybe it needs to create some other records, or maybe it needs to flag a process date, you know, with today's date or something like that, or send out an email, or automatically create another object which will automatically keep track of an order and the status and stuff like that. And whenever the status changes, it knows it needs to go to the next level. So it's based on, you know, the business requirements and the flow of the program. And what we want to be able to do is whenever something needs to change in our model, and this isn't so much in our model, but it's going to be, it's kind of a work in progress to show the processes. I'll give an example here. These pink objects show this Inspire object. This basically means if somebody gets nominated, employee gets nominated for an award, somebody goes in and makes that nomination, they nominate some other people, and each one of these people that are nominated has to be approved by their manager or a hierarchy of managers. So manager, and then that manager's manager, all the way up to however it's defined for the award. So what we have going here is this object is input in the UI. The employee can go in there and say they want to nominate somebody. They then find or do a search on the list of employees, again using employee search, pick one of them. As soon as they pick one, it adds it to a list, creates this object for Inspire recipient, and then knows what employee that's for. Now that we have the recipient, now what the user doesn't do, but we need to have automated, is it needs to automatically go and create this Inspire approval. Inspire approval means go to this Inspire recipient, their employee, find out who their manager is, create an object here with that manager, and we need to then wait until this manager either approves or denies. Once they approve or deny, if they deny it, we're done. We need to update this to say it's completed, send out an email. If it's approved, we need to see the type of award that this is for, and if it needs to have another manager approve, we need to then find this manager's manager, create another object here, and mark this one as completed. Well, this one will be marked as completed because they have a status of approved, and that will automatically set the status date, because if we looked at the code, that's what that does. So these controller code that we were just discussing and that we're going to look at some more is basically set up so that it does all of the flow of it, the business logic type stuff. And again, I got some stuff for the model that's going to show that interaction within the model, and that'll give us a really good view of kind of the whole process. Not really a sequence diagram, but something similar to that, to show that these objects have interaction, have a process running behind it that will connect and fill out certain things and do certain things. So back to that, if we look at the controller, okay, one of the things is we talked about how this is a distributed system. So we have the server, and then we have the clients, and along with that, it's not distributed objects like a RMI object would be a lookup object on the server and all the methods always call it. There's a lot of overhead in that. Instead, what it is each client has a copy of the objects, and there's messaging that keeps them all in sync. So it's something like a product like a Terracotta or something like that, where they all stay in sync. And there's a messaging layer that obviously makes that happen, but it makes it pretty efficient. So what we want to do is to figure out where we want this code to run. So again, when something changes within those objects and something else, the change needs to be made because of that, then in most cases, we want to run on the server just because it's centralized, and again, it broadcasts it out. Everybody else stays in sync, so it centralizes is the main thing, and it ends up being more efficient too. So under the server, again, OA is all about this MVC stuff. So under the controllers, there's controllers for the client, which goes into everything about the client, and we've discussed that before in another thing. The same thing for server. Okay, under the server controllers, there's, again, under OA, everything being OA that we're talking about here has the different controllers. So just like the delegates only show the ones, it's the same thing here. So I can look at my model, look at my code, look under here to see what objects have controllers, to know there's some additional functionality going on there. What's nice is the server itself has something called this object controller. Its job is basically to start up all these individual controllers. Another job that it has is it will allow a thread pool to process stuff in the background, if that's the best way to do it, which in most cases it is. Or it kind of depends. Sometimes when a change is made, part of the event handling needs to do it at that point, and it needs to happen on the client. So it just depends on what the event is. But in this case, the example that we're using can be basically a process that runs on the server, can run on another thread, and in this case it sends out emails, does some other updates and stuff like that. So it doesn't need to be right in sync with the actual event or the event that happened. So this object controller, and this is not, none of these controllers are generated from OABuilder, but all of these come from the template project. We talked about how when OABuilder generates the whole application, it grabs it from the template project. These all come from the template project. But what's nice is we can customize these as much as we want, and we don't have to worry about them getting overwritten the next time we generate that part of it. So the template files do not get overwritten. They have some stuff that will be filled in, and then anything else that we put in there is custom, stays in the code. The code that OABuilder does generate, the OA objects, all the code that we've looked at up till now, does get generated and will get overwritten, and it will tell you that when it starts up. But the template stuff, all this stuff just comes from a project, and then we can be safe to customize it and stuff from there. The other thing with these files that come from template, if I ever go in and add some new functionality, just say into this project that I want to be involved in other projects, I just go add it to my template project once I know it's cleaned up in the way that I want it, and then I'm constantly building up some new functionality that I can use in all my other projects and future projects. That's usually how it's grown thus far. So the object controller will basically create, let's see, there's a start, we'll create all those other ones, and they basically just have a way that they're set up that they can have a start and stuff like that. And so under the Inspire, for the Inspire recipient, we basically have some code that needs to run to do the management, to do the housekeeping, so to speak, of managing those objects. So what's nice is it's this one object, it's what it's supposed to do, it's what it's supposed to listen for or wait for to happen, and whenever that happens, it's going to go ahead and do its thing. So that's what this code does, and I won't go into it too much, but it shows how we can get real-time updates to events, to whatever specific change we're looking for, and then when that happens, if we want to put it in a background thread, we can automatically do that. So it'll take it out of the thread that's actually sending out the event that's happening, and it can put it in a background thread, and all that code just comes down here to an abstract method to say, hey, run this. And again, that object controller, its job is to run it. The job here is just to say, set up what we want to run. In this case, we're going to update something, and it will automatically run all this code. This is all code that's really specific to fulfilling whatever's supposed to happen during that event. In this case, it has to go through this approval process, so we got to go find the manager, we create this other object, and all that stuff. And the whole time we're doing that, it creates new events, which basically means it's keeping all the client applications up to date. If we have a filter or a list or something that's showing all of the open approvals that are waiting, it would automatically be in that list, which we do have in our UI. So you would see all that being updated. Also with this, I don't think it's in here, but when these changes are being made and we're automatically creating this Manager's Inspire object, emails go out. So there's an email delegate here, or email controller, that's listening for all things that deal with the emails, and it's doing a very similar type of code for anything that pertain to emails. So what's funny is while this is running, it's generating and creating some new stuff and changes that this other email controller is going to then respond to send out an email. Really, it creates an email and puts it in a list of open emails that need to be sent out until we know that we can trust they can go on their own. So that's a lot, but that kind of completes these objects being able to run kind of like an engine, where it's all ticking and tying. And what's nice about this code is this really shows how the objects work together, how the event handling can be set up and stuff, and it doesn't take too long. I do some more sessions on exactly how all this works, and kind of again back to the whole cookie cutter. All these are just OA objects, so that have additional custom properties, data about it. And then there's also hubs or collections of objects. So from this object we can go get a list of all the from the Inspire recipient, we can go get all the Inspire approvals. We're going to loop through those looking for certain things, and all this is based on exactly the properties and stuff that are defined in our model. So this is just showing us using that in code that goes through it. The other thing that this shows is actually listening for events. So as this code, update that's the delegate. So this code here in the controller, it wants to know when certain things happen, so it needs to basically listen for those areas where that can happen. So in this case, it's listening to the whole cache to see for any changes to an Inspire recipient, because it might need to do something. Again, its job is to do the housekeeping for these things and do any processing when certain things happen. The other thing that's going on is here's another listener that we're going to set up. Here's the code that we have that's customized for that listener, and then down here this is what we're listening to. So what's interesting here is back to the example of the Inspire recipient and the manager's approval and all that stuff, is if there's Inspire recipient and their manager or a manager in the hierarchy changes, we need to also make some adjustments. So what this is going to do is this is automatically going to listen to the employee's parent employee, which is the manager. It also knows that this is a hierarchy, so it's going to go up the hierarchy to listen. All this just in this code, and then it's going to automatically create this list to go ahead and listen to it. And again, it's going to use this hub listener to automatically listen to any of this. So, and we created this dummy property called XX that we're listening to, and this will automatically recalculate based on the fact that a manager changed. So we don't have to do any processing. We don't have to have any other outside messaging going on specifically for this type thing. So it allows our object model basically to flow. Things are getting changed. The user can use the UI, the website's being used and stuff like that. And behind the scenes, again, kind of like an engine, we have things plugged in. It's more like a circuit board. So when certain things happen, it kicks off something else to happen. So you get this kind of chain reaction to make all that work. And again, what I was saying about the emails, some things that happen in here need to also send out an email. There's no code in here that even cares about email. It basically says, my job is this. The email controller, its job is to do that other thing. So under the email controller, and we won't go into this too much, But if you look at this, this will be listening for Inspire approvals and a whole bunch of other stuff, because we have a bunch of emails. It's listening to all those trigger points or events to happen, and it will do its thing to send out emails. And its job isn't to send email. So its job is just to listen for the condition that needs to then do something about an email. And then we have this email delegate that will call and say, okay, we just found another a condition, or captured or trapped or whatever you want to call it, got a message about a change that needs to generate an email. And over our email delegate, we can tell it to go ahead and send an email based on whatever parameter it is. And we'll get a little bit more into this later on how that works. Email delegate, its job is just to form an email, and I think it does have a method to send it, but put it in a list of open emails so that we can have something, a UI way to kind of release those emails and say, okay, send them out into the wild, and then the whole process is done. So I think that's enough for this video. I'll talk about the other code generators in another session.